All right, so today we're going to take a look at the rest of section 10.4 and finish up talking about Pascal's triangle. We talked a little bit last time about Pascal's triangle. We just barely got started, and we had taken a look at this triangular array. So I'm not going to give you enough time to write all this down, so if you don't have it with you today, just know that you can go out online and find it, or you could find it from your book. What I want to start in with today is the next triangular array that has correlation to this one. So we're going to take a look at the combination values in Pascal's triangle. I'm not going to write as many of them down, that is, as many rows down, but we're going to go down from row 0 to row 5. So on row 0, in the very center, just like you wrote this very center, it was the number 1 on the previous slide, you're going to write 0, C, 0. All right, so 0, C, 0 means you have 0 elements to choose from, or 0 things in your sample space, and you're choosing none of them. Okay, I know that sounds sort of weird in and of itself, but that's what the numbers would mean by comparison to what we've been doing. So we're going to do the 1 then. And so again, off center from a 0, C, 0, a little bit in each direction, we're going to write 1, C, 0, and then 1, C, 1. All right, now we're on row 2. Again, off center and to the outer edges of this, we're going to start on the left-hand side with 2C0. And then right underneath the very top pinnacle of my triangle, that 0C0, I'm going to write 2C1. And then on the right-hand edge, I'm going to be writing 2C2. I promise I'm going to explain this all when we get there, okay? Let's do a couple more rows. Row 3. So I've got 3C0, 3C1, 3C2, and then 3C3. Let's go one more row. Well, I'll do 2 more rows because I did 2 more in my other class. So we have 4C0, 4C1, 4C2, 4C3, 4C4. And we'll do 5th row, or row what we're calling 5th row, 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. And if I asked you to keep going, you could do row 6, right? Yeah, okay. So what I want you to see between this triangle and the other one is that they're related. You knew that though, right? So let me show you how they're related. All right, let's say, for instance, we looked at 3C1. We're just going to pick one of them, okay? 3C1, what row am I on? Row 3, okay? And I'm in the second entry of row 3, agreed? It says C1, but I'm in the second entry because it starts out with zeros, okay? We're going to go back to the other slide and go to the 3rd row and go to the second entry. 3rd row, second entry is right here. This is the number 3. That 3rd row, second entry is equal to the 3C1 that I was in the 3rd row, second entry on this Pascal triangle. All of those combinations are the values from the Pascal triangle. So here's the cool thing. If we're working a problem and I want to know in the problem what is 5C3, I can go to the 5th row, 4th entry, not 3rd entry. It's always one more on the entry line, right? 5th row, 4th entry. So I go to my 5th row, I go to my 4th entry, I'm right here, and 5C3 is 10. So in this section, you will not be using any factorials. There's something to clap at that. Well, right, so it's something a little bit different. There's a relationship here, there's a geometric component. It's just very different, and it's a very interesting application of Pascal's triangle, that it has these combinations embedded within it. Because I don't know about you, but if you remember last time we did this, we didn't create Pascal's triangle from counting anything, did we? No. We added up the 2 previous entries, and we did a bunch of addition. That's all we did to create that Pascal's triangle. And it has, in and of itself, this relationship with combinations already built in, which is pretty cool. So here's what we're going to do. We're actually going to do some problems related to Pascal's triangle, and we're not going to see any factorials in them. What we are going to do for the work that you have to show is you're going to write something down like this. So this is 6C3. So if I were to go into Pascal's triangle, I'm going to write down what I'd be looking for. So 6C3 means I'm going to go to what row? Sixth row. What entry? The fourth entry.
Wait, how do you figure that out?
Somebody tell Mackenzie, how do you figure out it's the fourth entry?
Because each row starts with 0.
The row starts with 0, right? So if the, oops, I'm sorry, I went too far. If the row starts with 0, then this is the first entry is 0. The second entry is 1. The third entry is 2. So whatever entry we have, it's 1 bigger than the value that's coming second. So this says C3. What's wrong? Did I screw something up?
No.
No. You had a question? Oh, you want me to go back for a second?
No, that's okay.
Okay.
No, I was just saying, like, did you say we have to write the 6th row, 4th entry?
Yes. You're going to write down 6th row, 4th entry as part of your answer. We're not quite there done yet. Yeah. But the 4th entry is coming from this 3 at the end. The C3, 3, you add 1.
So if it was 4, do you like the 5th?
Yes, it would. Yeah. All right, so 6th row, 4th entry. We're going back to the original triangle. 6th row. What is my 4th entry? 20. So the answer to problem number 1 is 20. And could you verify it in another way? Sure. It's called factorials. We were doing that before, right? But that's not, you don't have to verify it, no. But for those of you who tend to do tests fast, and there are some of you who do, it wouldn't be a bad idea if you were in the middle of a test to make sure that you answered that correctly, right? Sure, why not? Okay. Some of you don't do tests fast, don't do it, but some of you do. All right, 8C6. What row, what entry?
8th row, 7th.
8th row, you guys got the hang of this already. 8th row, 7th entry. So, go to the triangle. 8th row, 7th entry. What do you have? I counted to 28. Did you get 28? Okay. So, we have the 28th as our value. All right, so, word to the wise. You have a test coming up next Friday. And you get to use something on the test called a note card. What might you want to write on the note card? Probably be a good idea. Now, you probably don't need to write, like 15 rows of it, right? I mean, you could if you really wanted to. But if you went to, 5 or 6 or 7, something like that, and you needed more rows than you had, could you recreate it on the spot? You should be able to. It was just addition, right? It was just the way we structured it. Okay, so that's what we would be wanting to make sure we probably think about towards your test and maybe think about what goes on that note card this time. All right, let's take a look at some other problems. All right. Suppose a committee of 3 people is to be selected from among 7 women, 3 men. Find the number of ways of obtaining each result. All right, so this says we have exactly 3 women. How do I find that out? Okay, say it louder for me, please. That is 7C3. Where'd you get the 7 from? Yeah, because it said what is 7 in the word problem? It's the number of women, right? We're talking about how many women we're picking from. We got 7 of them. You bet. And the 3 came from the fact that we want to pick 3. 7C3. Are you going to use factorials in 10.4? No. And I'll tell you on the test if I want you to use Pascal's triangle or to use factorials, okay? So you don't have to worry about that. But when you're in 10.4, you're using Pascal's triangle. That's the whole point of the section. So somebody tell me what I'm going to write down for the work for this. 7th row, 4th entry. And if you look back at the 7th row, 4th entry, what is it? It is 35. Did everybody see that okay? All right. So this is 35. Perfect. Let's take a look at the next one. You ready? Oops, I'm on the same page. Exactly 3 men. Yeah. You're going to say it too? Say it really loud, DJ.
It'll be 3C3.
It will be 3C3. We got it from both sides of the room. Perfect. Now, I know that some of you probably know what 3C3 is, but if you're looking for Pascal's triangle perspective, what are you looking for? Third row, fourth entry. And what is on the third row and in the fourth entry? It's 1. It's 1. Okay. The next one's harder because it involves having some men and some women both on this committee. It says exactly 1 woman. So, by default, go back to the problem, it told me that I'm going to create a committee of 3 people, right? So I'm not just picking the woman, right? It says exactly 1 woman, which also means what's going on. Okay? By default, this means and 2 men. So let's first talk about the woman. These are 2 parts to the same problem. First, the woman. How do I pick the woman? That's 7C1. And this is multiplied by the next part. How do I pick the man? That is 3C2. Yes. 3 men to pick from, and I choose 2 of them. All right, so we're going to write down each of these one at a time. 7C1 is what? How in that triangle am I going to find that? 7th row. Second entry. How about 3C2? 3rd row. 3rd entry. All right, let's go and do both of those. What is the 7th row, 2nd entry? It is. It's a 7. And what is the 3rd row, 3rd entry? It's a 3. 7 times 3 is 21. Okay, we've got one more. Exactly 1 man. So what's that mean?
2 women.
It means by default I've got 2 women as well. All right, so let's do the exactly 1 man part. How do I get exactly 1 man? 3C1. And how do I get the 2 women? 7C2. The work I need to show has to do with the triangle. So 3C1 is 3rd row, 2nd entry. What is 7C2? 7th row, 3rd entry. All right, 3rd row, 2nd entry. What is that?
3.
It is a 3. And the 7th row, 3rd entry? It is a 21. What is 3 times 21? 63. Beautiful. Any questions on that? Okay. Yeah? No? We're good?